how to identify domain and range. So this can be very confusing what this is. Sometimes we talk about domain and range in terms of like a function. Sometimes they'll represent it like, oh, that's much thicker than I expected. That's okay. They'll do something like this, and they'll tell you these are the x values, these are the y values, and there's a 1 and a 3, and a 2, and a 4, and a 6, and they'll do something like that. Or maybe they'll have a graph, and they'll plot a bunch of dots. Yeah, that's common. Or maybe it'll be something like this, and it'll be a continuous. And this will be something continuous that has like a curved line or a line, okay? And we have to represent these different things. Domain are, let's write in, domain are x values, okay? So how can we represent all the x values in something? In the range,
you put it in the
y values.
The bracket thing,
Yeah.
the fancy bracket.
Yeah, so depending actually. So this is continuous. If it's continuous, we actually use something your teacher calls it here, interval notation, where we say something like the domain is equal to, you might say like x is every real number. They may not have you write that part, they might. Then we put a vertical line such that.
She tells us just to write x and then that, such that.
Yeah, such that. So you probably don't have to write that value part in, so maybe it's just like this, x such that. Some people don't even write that part and they just write the restrictions of it. And we'd write restrictions. It could be like, -5 is less than equal to x is less than equal to 10. And that just means it's between those values.
Mm-hmm. But what I don't get is, why do you put like equal? Why do
we're
you
going to talk
the
about
equal?
that. We're going to talk. I'm going to get an example.
Oh wait, never mind. Actually remember.
You remember? Okay, good.
It's with the dot
this here.
things.
Not the dot things do matter too. These ones are called discontinuous. And discontinuous, did they give this one a name? The style they write here? No, this one is just written kind of like this. We have like a set of brackets, and you might say the domain is equal to -2, -4, or -2, 4, 6, and 7, and brackets. And the range is, well, in this one it looks like the range is like -2 and a 1 and a 2 and a 3 maybe. I'm just doing some estimating. So what you're going to notice is this notation here with just numbers is very different from our interval notation. But these are the two main ones we use when representing stuff. So what I'm going to do is I'm going to jump into this program here. I'm going to turn that off. So we're going to focus on just these. Okay. Take a screenshot of that. And we'll go back into this program. We're going to insert that screenshot. Great. So we have these here. The way we're going to figure this out is, we got to figure out what the domain is. So we're going to actually just go about underlining the x values here. Okay? So if you notice, I have 4 x values. Okay? So I would say the domain in this case.
Can I get scissors? Not the blue ones. Not the other ones. I like these ones because look.
Okay, be careful. The domain here is those values, okay? So I would just put a set of curly brackets, and I write the numbers in order from lowest to greatest. So we have a 2, a 3, a 4, and a 5. Are any of them duplicates? No. So we leave them. That's it. The reason I write it that way is because there's nothing between these lines. Do you notice that? This is not continuous. This is considered discontinuous, okay? So then range, we are with a colon, curly brackets again. What are all my y values? Well, I have an 8, and an 8, and an 8, and a 12.
So you only have to put the 8 once?
Yeah, exactly. Because those are the same, we can rewrite this. And I only wrote them all out to show you. When you glance at it, you'll very quickly realize there's only 2. 8 and
But when can we
12.
just do it like that and not with the x such that?
Because this isn't a line.
If she just gives us points, like, if she just gives it to us and then she's like, lists the domain and...
Range,
okay.
it's just the coordinates. So if I were to just draw a dot, This is something like 4.5 and 10.5. So let's say it's like 4.5 and 10.5. This isn't continuous. But if I do this, very different, because there's an infinite number of values along this line. I can zoom in forever and find decimals. That's when we use interval value, okay? So let's go. Let me get rid of that. Should use a much bigger eraser. That's easier. There we go. This is when we use just the values themselves, okay? Let's go back to decimals. Okay, I'm going to turn those off. They disappear. Now this, that is continuous. Oh my gosh, I hit the wrong thing. And actually what I do, no, actually I'll leave that. Take a picture of that. Let's go back. Add it in here. Here we go. This is continuous. Now, I'm going to point out that this value here is 1 and 3, okay? And this value here is 5 and
So that means that
2.
the points are included.
Yeah.
So that's when you use the equal sign.
Exactly, yes. Because everything, I'm going to do my best to cover this line, everything from there to there is included. Can you imagine having to write all those numbers out? I could. I could say the domain is 1, 1.1, 1.2, 1, but even then, Sophia, that's not
1.1.
I have to do 1.11. I can keep going. It would be infinite. I never finish writing all my numbers. It's ridiculous. So we never write it that way because that's way too much work. Okay? So what we do is we represent it like this. We'll say that the domain is X, and then I think yours writes such that you don't write every real number. The reason we say every real number is that because that represents all the decimals, okay? What is it between? Well, what are the two X values it's between? It's between 1 and 5.
I think I know what the thing is.
So we write 1.
1 is...
5.
Oh.
We write an X.
And then is little... Wait, is that the greater one?
So when we read left to right. But this is how I want you to think of it. Is X greater than 1 in this example? Yeah, so think of it like X is pointing, whoever's bigger is pointing at the other one. So X is bigger than 1, so he's pointing at 1. And is 5 larger than all the other values?
Yeah, but it's just because in this thing, 1 would be considered greater because 5 is lower.
This is the X values. Think of it horizontally. Vertically in the range, there's going to be a difference. But this is left to right, actually. Think of it like this. Domain exists from here.
Oh, so 1
here.
would be smaller.
Yeah,
okay.
so this is 1 and this is 5. That's where our domain lies. Okay? What about range? I'll do it in green.
Okay, range is y.
Yes, y
Y
such that. What's the
3.
Okay.
Oh wait, -2.
Mm-hmm.
And then 3 on the
3 on the other side. Okay.
And then it's less than
So
less
like that.
than or equal to.
Yeah.
And then
Y and less than equal to 3. Okay, and the reason we write it like that is because your range goes from 3 to -2. Now, I'm going to show you. I could technically write this the other way. I could say the domain is X such that 5 is greater than and equal to X, and X is greater than and equal to 1.
would that still be correct?
That is still correct because my signs are pointing the other way. It's common to write, just for the reader's point of view, the lowest number on the left, because we read left to right, to the highest number on the right. But this isn't wrong, what I'm doing. And the range could be Y, such that 3 is greater than and equal to Y, which is greater than and equal to -2. Okay? I'm going to put my brackets around. All of those are correct in this instance. Okay? So it doesn't really matter which way we do it, though one way is more practiced than the other. Okay? So